Previous lecture I explained the early effect and we obtained the input characteristics of common base transistor. In this lecture we will obtain the output characteristics of common base transistor. It is the graphical relation between the output current and the output voltage for various levels of input current. The output characteristics is the graphical relation between the output current and the output voltage for various levels of input current. If you see the common base configuration of transistor, you will find IC is the output current and VCB is the output voltage. So output current is IC, the collector current, and output voltage is VCB, and the input current is IE, the emitter current. So we have to plot the graphical relation between the collector current IC, voltage VCB for various levels of emitter current IE. If we consider this NPN transistor as two diodes connected back to back, it will look something like this. This is the first diode and this is the second diode. We want to plot the output characteristics of common base transistor in active region. So the first diode is forward biased and the second diode is reverse biased. Current through the second diode is IC, the collector current, and voltage across this diode is equal to VCB. So the output characteristics is simply the reverse bias characteristics of diode. Very simple. You can see this diode is reverse biased. The current is IC, the same current as in output characteristics, and the voltage across the diode is equal to VCB, the same voltage. So the output characteristics of common base transistor is simply the reverse bias characteristics of PN junction diode. The x-axis will represent VCB and the y-axis will represent IC. IC is measured in milliamps and VCB is measured in volts. The plot is very simple. It will be simply the reverse bias characteristics of diode, but the important thing is variation of the plot for different levels of input current, that is IE. And we already know the collector current IC is equal to alpha times IE plus ICBO, where ICBO is the reverse saturation current or leakage current. ICBO is very small as compared to alpha times IE, so we can neglect ICBO, and IC is nearly equal to alpha times IE. You can also see in this first equation there is no VCB, so this is independent of VCB. Now we can consider the collector current IC nearly equal to the emitter current IE, because alpha is from 0.95 to 0.98, which is nearly equal to 1. So we can say that the collector current is equal to the emitter current. So the output current is affected tremendously by the input current. When input current, the emitter current, is equal to 0 milliamps, then the output current is nearly equal to 0 milliamps. This small current is ICBO, the reverse saturation current. When IE is equal to 0, IC is equal to ICBO. This is when IE is equal to 0 milliamps. When IE is equal to, let's say, 5 milliamps, IE is equal to 5 milliamps, the collector current is nearly equal to 5 milliamps, and the plot will look like this. In the same way, when emitter current IE is equal to 10 milliamps, the collector current is nearly equal to 10 milliamps, and the plot will look like this. So this is the output characteristics of the common base transistor, and this region is called active region. region, and this region here is called saturation region, and the region below IE equal to 0 milliamps is called cutoff region. Now there is one very important thing that I want to explain you. What will happen if we go on increasing VCB? What will happen if we go on increasing the reverse bias potential? There will be breakdown. We already know in reverse bias condition, if we increase the reverse bias potential, after some time there will be breakdown and the current will increase rapidly. So if we increase VCB, the point will come when there will be breakdown and the current will increase rapidly. But this situation never arises because transistor cannot withstand the high power being dissipated. So this situation will never arise. Now if you invert this plot, you will find it is similar to the reverse bias characteristics of PN junction diode. You can see this plot is similar to the reverse bias characteristics of PN junction diode. The next thing is the cutoff region. In cutoff region, both the diodes are reverse biased and transistor will remain off. When transistor operates in this region, we can consider transistor as open switch or logical off. In saturation region, both the diodes are forward biased and we can consider transistor as closed switch or logical on. You can see collector current IC, it starts to reduce and becomes 0 in saturation region, and this is how we have to plot the output characteristics of common base transistor. If you have any doubt, you may ask in the comment section. I will end this lecture here. See you in the next one.